Welcome to today's Energy Central webcast entitled Optimizing Your Demand Response Program Using Big Data and Bring Your Own Device. A few housekeeping notes we'd like to mention. For best results in viewing the presentation, we recommend using a wired high-speed internet connection, as wireless connections can be unpredictable. If you cannot get adequate sound from your computer speakers, you may dial in using the telephone number listed in the audio section of the interface on the right-hand side. Following the presentation, we'll have a brief question and answer period. You may submit your questions at any time using the interface on your screen. Now I'd like to introduce today's speakers. Here today to discuss how to optimize your demand response program using big data and bring your own device are Converge's John Rossi, Senior Vice President of Corporate Strategy, and Chris Ash, Vice President of Product Management. John co-founded Converge in 1997 and has held a variety of roles within the company since. Prior to joining Converge, John spent 25 years at Bell Laboratories, the research and development arm of AT&T and Lucent Technologies. Our second presenter, Chris Ash, is responsible for Converge's market analysis and product portfolio management that drive the company's software and hardware product roadmap. Over the past 2 decades, he has worked extensively with utilities in the U.S. and internationally on all phases of the major projects. Now I'm happy to turn the floor over to our first speaker, John Rossi, to kick off today's event. John, welcome to the event. You have the floor.
Thank you, PJ. Today we'll talk about 2 related topics. First, I'll discuss the growing number of third-party Wi-Fi thermostats being sold and installed by customers and how these devices might be used as an asset in a utility demand response program. Next, Chris Ash, who we refer to as the Crocodile Dundee of demand response, will tackle the topic of how utilities can use the data coming from these Wi-Fi thermostats, AMI, and other sources to improve DR programs in many ways. Finally, we'll allow time at the end for questions on these topics. So again, the agenda is shown here. I'll discuss the bring your own devices, and Chris will talk about how to use these devices and others to improve utility programs. Next slide, please. This is the topic of my presentation, Valuing Third-Party Resources in a Bring Your Own Device Program. Next slide. This is the big picture of how the third-party devices, which you see across the bottom of the screen, feed into a utility program through an aggregation layer. The aggregation layer is critical to the success of a program, but the proper rules and incentives need to be in place to make these third-party devices provide the maximum value to the program. Next slide, please. So why bring your own devices? Why is that an interesting topic? First, from a utility perspective, this is a potential new way to add customers to the demand response programs. It has the potential to save money on marketing and installations, for example. Second, a thermostat connected via a broadband connection allows the potential for fast dispatch and also for feedback on performance. Not only that, but a broadband connected thermostat can be an asset for energy efficiency as well. If we look at this from the third-party device vendor perspective, the device providers would like to monetize the asset that they have in the customer's house by selling load to the utility program. Without this method of monetization, most of these thermostats are just a cost center to the provider because they have to have the support software to allow the customer to access the thermostats. On the other hand, some of the providers of third-party stats have a variety of rules for how their devices can be used. We'll explore this in a little bit more detail And these rules vary from manufacturer to manufacturer. Next slide, please. We characterize third-party providers into two types. The first type is a provider who allows control of the device by going through their head-end system, and they provide bidirectional access to the individual endpoints. A type 2 provider, in contrast, allows no access to the endpoints, but they will dispatch those endpoints if called upon by the utility or the aggregator. The reports that this type of provider gives are on a population-wide basis, not on an individual basis. I have a few pictures in the next slide, please, which shows this in a graphical way. You see the type 1 provider has individual bidirectional arrows from the aggregation platform to the third-party head end, and from that head end to the devices. Whereas the type 2 provider has a single dispatch for the entire population, and then it goes through their head end, and they address the individual end devices. I go through each of these on the next slide, please. So here again, a type 1 device is a pass-through access where the aggregation platform can get directly to the endpoints, and the endpoints can be seen by the aggregation platform, again passing through that head-end system. Next slide. Again, in contrast, the type 2 device provider is a bulk dispatch, and aggregated data passes between their head end and the aggregation platform. We view this very similar to the kind of load and the kind of arrangement that an ISO may have with a large industrial customer, where the industrial customer bids a set amount of load, and the ISO validates their performance based against that load bid. So that's the way we view a type 2 provider. A type 2 provider may say, I can give you 1 megawatt over the next 4 hours, or whatever the term may be, and then we assess their performance against that bid and pay them accordingly. And I'll get into a little bit more about the rules later in the presentation. So next slide, please. So from a utility perspective, I think we have to get this right. As you know, a utility has responsibilities beyond that of a thermostat provider. Basically, you have responsibility for 100% of the customers in your territory. You have responsibility for the reliability of the system. You're regulated to make sure you live within the rules, and you're mandated and judged on cost effectiveness. Importantly, you're responsible to all customers. If we contrast that to a third-party stat provider, their customer base at the current time is in general less than 1% of the total number of customers. They have no reliability requirements on a system-wide basis. They're unregulated, they're a for-profit company, and they're answerable to their end customer for warranty reasons only. So this is a kind of a stark difference between the two. So let me illustrate this with a little picture. I think it's important to note that, excuse me one second, my computer went offline here. Just give me a minute. Sorry. So I think this puts in perspective our view of the business relationship between the utility and the third-party providers, in that the utility has the bulk of the responsibilities. Hence, they have the requirement to make sure this program is correct. Let's go to the next slide, and I'll illustrate an actual tariff from an unnamed utility where, in our opinion, the tail may be wagging this particular dog. The program rules call for a $100 subsidy for the customer acquiring the device and a yearly payment for participation in events, where participation is defined as contributing for 50% or greater of the called hours of the program. So on the next slide, I talk about a realistic scenario of what could happen in this particular case. The utility is very likely to call 3 or 4 hour events late in the day. Let's assume that the customer comes home in the 3rd hour and changes their thermostat set point to, in essence, opt out of the control event. Since they had been in control and now they went back to their original setting, there will be snapback where the compressor will run more than normal to make up for the time that it was held off. The net of energy over the event period will be reduced because of this action. And more importantly, the load shape here is very bad from a utility perspective. Again, I point out that this is not an unreasonable scenario. But let's look at the next slide where we'll see the load shapes that may occur versus what the utility would want this load shape to be. Here's an ideal load shape where you have a load drop for the duration of the event, and this snapback that I referred to is beyond the event time. You can see that more clearly on the next slide where I shade in the load drop and the snapback. So again, the load during the event is predictable, and the snapback is outside of the event period. If we go back to my previous example on the next slide, where the customer overrides at that midpoint in the event, then you can see that the snapback is during the event period. Again, I shade the colors on the next slide. So you see that snapback occurs during the event, and this provides a load shape that's not only difficult or impossible to predict, but it's hard to compensate for this load shape with load from other participants who may be in the program. So if we look at the next slide, we suggest a number of rules that may be put in place to get usable load, optimal load, from these third-party devices. The key here is to establish a pay-for-performance structure so that you get what you're paying for. And the aggregator in this case could enforce those rules on the third party. The first item in the chart here is pay for performance, where the payment is for kilowatt hours delivered versus a baseline, settled hourly based on AMI readings. The second item is availability, and clearly here, the faster the response time, the greater the value. So it could be a 10-minute dispatch, a 30-minute dispatch, or the least valuable is a day-ahead dispatch. When we go to the third item of capacity payments, we would suggest something like you would pay the provider for delivered load at 0.75 to 1.1 of what they bid, with no payment below 0.75 of their bid. If we look at item 4, the load shape during the event, again, we would have pay for kilowatt hours below the baseline and a penalty for kilowatt hours above the baseline. The next item, the fifth item, is portfolio registration. The utility and the aggregator must know in advance who's in the control population before the event. That information could be updated monthly, but it should be updated 10 days in advance of any events, and there should be no change after that until the next monthly period. And then the energy payment penalty, the last item here. Again, it's settled hourly on a per kilowatt hour basis below the baseline, and a penalty of 2x for kilowatt hours above the baseline. This penalty could be 2 times the bid price, or it could be the market price, which you have to pay to replace their deficient energy. That's another option for this. So I summarize in my last slide here. Next slide, please. The utilities should develop realistic program rules that pay resources for the actual value that they provide. The aggregation platform that I showed on my diagrams is necessary to blend load shapes and to settle with the third parties based on the program rules. And the more devices you have in a program, the more complex that this process becomes. And Chris will talk a little bit more about that in his section. When you have an aggregator in the loop, the aggregator should be willing to take responsibility for these type 1 loads because they have direct control and direct feedback from the endpoints. So they should be willing to take performance risk for a type 1 provider. And in order to do this, you really need someone who has utility-grade demand response experience. In contrast, for type 2 load, the third party, the thermostat vendor, is responsible for event performance and is paid or penalized accordingly. So my next slide, I'm going to transition over to Chris Ash, who will discuss how we combine these third-party assets with others to provide not only demand response, but other benefits to the utility and to your customers. With that, I'll turn it over to Chris.
Next slide, please. Okay, thank you, John. It's a pleasure to be the second member of this panel. I like to put it this way, what John said, is he told us there's a better way to harness bring your own device than the trajectory that some of the pilots and the early programs have been in. What we've learned is we really need a useful load shape. What we've learned is we really need to reward for the value of the DR. And then on John's last slide there, we should not just harness DR through bring your own device and forsake energy efficiency and consumer engagement. How do we harness that as well? Next slide, please. Okay, so let's talk about the first of these topics. How do we go about doing the first thing? How do we go about making the load shape useful? And here's the essence of the problem. When one device cycles one way, another device cycles a different way, another device pre-cools and does a temperature offset and then does a snapback a couple of hours later. How do we distill what we call a quality megawatt from all of those sources? And let's take a little journey down a recent history here. This problem has been solved very recently. And the way we should solve it in a BYOD world is born of the same approach. A lot of you probably remember, there's this trend in this industry, and it's this. We want a quality megawatt, availability, reliability, predictability, sustainability. So when we forecast 50 megawatts, we want 50 megawatts. We spend a lot of time in the operations centers or control centers of utilities And we know this is nirvana, to make DR as predictable as, say, a gas turbine peaker. And it be used that way when you need to offset other resources, make some energy trading decisions, have it orchestrated with intermittent renewables. We need it to be a quality megawatt. And I think our opinion is that just because the sources of the load come from a bring your own device model, they shouldn't be excluded from this goal of turning demand response megawatts into quality megawatts. Next slide, please. So again, continuing down history a little bit, how have we solved this problem? There's two dimensions, forecasting and dispatch. So let's talk forecasting. The answer is to use all the data that we now have at hand, particularly the telemetry that comes from these two-way devices. This bring your own device world right now is dominated by Wi-Fi thermostats, and they throw off all of this telemetry data that we can use. Combine that with weather, AMI, customer demographics, and things we've captured about the appliance and things about we know about the building, are all the data sources used to distill a quality megawatt. What it means is, any decent DR vendor like we are has made substantial investments over the previous years in a new big data solution to answer questions like, what is the load going to be tomorrow at 2 o'clock if it's 92 degrees with all of these inputs? We need to know that. It's very different to a more traditional approach that maybe an M&V report next week or an M&V report at the end of the season will tell you what you got. Here's some additive nuances of how this works in a BYOD world. It's not just the shape of the event. If there's some pre-cooling going on or pre-storage in the event of a water heater, plus the load during the event, plus the snapback, we want to be able to forecast that whole load, that whole shape. It's absolutely needed in a BYOD world. So not for this webinar. Will we dive into this next topic very deep, and we're very happy to do lots of follow-ups, but there's some super interesting insights into how this forecasting works. There's a lot of tribal knowledge about what's important. Is AMI data important? Is cloud coverage important? You can cut through all of that when you have data and train a machine learning system to tell you the facts, not the tribal knowledge about what's important when doing forecasting. Next slide, please. Okay, the other portion of this problem is dispatch. How to dispatch a quality megawatt. So not only do we have to deal with the different shapes of load that come from these BYOD sources, as John mentioned, there's a variety of rules about notification time, and when you call them, how long can you call them for? So this problem has been solved before in the CNI world. We've done it a lot. When you have a resource that can come on in 5 minutes, but it can only be used for 30, you use those first while you bring on the next tier of resource that needed 30 minutes to call and can be used over multiple hours. So the BYOD nuance to this is, how do you do that with 50,000 connected devices and not 1,000 large CNI facilities? Some other nuances of how this works in the BYOD world is to actually take into account real-time online-offline counts of devices, plus forecasting the potential opt-outs that are going to happen and the comfort of people. If I know I need, say, 18,000 devices to get to the megawatt value I need, I'm excluding the ones that are offline right now. I'm excluding ones of which I forecast will opt out, because I need to add others if I'm going to get to the megawatt prediction that I want. Next slide, please. So we're capturing here a little checklist. What does this better solution look like? As I said earlier, I really feel like just because the load comes from a BYOD source, we should not forgive it for being a normal megawatt. We want to get a quality megawatt from it, like we want to get from all DR sources in future. And tying this back to John's point, what that kind of leads us to is type 1 resources are probably better than type 2 if we want to distill a quality megawatt. Next slide, please. Okay, let's talk about the next dimension of what a DR program optimized with the BYOD should look like. I think this is a big deal. This is a big idea, right? That up till now, bring your own device programs, people have thought of them as being a way to harness demand response. No matter what the device and how the person got it, at 3 o'clock tomorrow in the afternoon, when you need it, call it for DR. But how does bring your own device work in the energy efficiency and consumer engagement realm? That's a big question. Can I draw your eye to the right-hand side of this slide? It's indicative of a mega trend in our industry. It's this convergence of energy efficiency and demand response. Here's how it kind of works. You've got a device, say it's a Wi-Fi thermostat in someone's premise. That device controls my comfort and impacts my bill. So my eyes are drawn to a portal or an application rather than it just being something I don't care about. So now my eyes are on a portal or on an application or receiving notifications about my comfort and my bill. I'll be receptive to EE tips, energy efficiency tips, that are personalized and actionable to me. And how do I get those? I get those because that device on my wall that I'm using for DR is throwing off a lot of data, a lot of telemetry data that can be mined to work out things about me and my premise and my AC efficiency. And then the cycle's complete. The device, my attention to it, me being receptive to EE tips, delivers a combined EE, DR, and engagement experience that has a really compelling TRC, total resource cost. And here's the other reason this is a mega trend. It's this anecdote. The anecdote is, if I leave my house in the morning and I put my set point way up, maybe by 3 o'clock in the afternoon, my internal temperature's not hit my set point. My AC's not run at all and won't run. I've entirely cannibalized my DR potential in that afternoon for EE. So these programs need to get designed together, and the M&V needs to be together, and they're intimately joined at the hip. So let's go back to the BYOD world on the left-hand side here. How can we get cost recovery for EE if a device worked its way into someone's premise through a retail or a trade channel, and us, the utility, had no reason or hadn't played no hand in putting it there? We either get to sell less energy with no rate recovery, and additive to that is for the precious small amount of time that the consumer will spend thinking about their energy efficiency and their bill, they're not engaged with the utility, they're engaged looking at the portal or the app of the provider of their bring your own device asset. So what do we do? There's 3 approaches to this. One is we absolutely need to open up a communications channel to the consumer by either attracting them to the utility portal and application or through the portal and application of the bring your own device vendor. One of our customers has a great phrase. I love it. He says, the utility has a unique value proposition that only they can realize. And it's along these lines. It's if right next to where I control my thermostat, it's telling me how it's going to impact my bill. It's telling me normative comparisons against other folks in my service territory. These are unique value propositions that only the utility can provide. Additionally, how do we make a programmable thermostat smarter and take credit for the EE benefits we're farming off of that? Just the act of putting a programmable Wi-Fi thermostat in our homes obviously has some evidence that there's an EE benefit. But how do we now then use that data, all of that telemetry off that device, and recommend different set points, different schedules, that are personalized and actionable to individual people. Additionally, how do we just farm this EE in general and actually cross-sell people into other EE programs around, insulation, or recommend to them a different size of AC system when they go to change theirs out? These are all ways that it's not just DR, but it's using the BYOD model to harness EE and engagement benefits, and not just embrace DR for the sake of those and forsake those. Next slide, please. So continuing on the checklist, what this leads us to is BYOD vendors that are, again, fit John Rossi's Type 1 model. Give us access to data, give us access to control, so we can harness EE and broker an engagement relationship. Next slide, please. Okay, let's talk about the next dimension of what the better BYOD solution looks like. As John alluded to at the end of his deck, we're actually running a residential thermostat market where we'd like to pay people for what they provide. And running a residential thermostat market is complex, really complex. We've learned this. Here's a couple of examples. How do I even know the devices in my service territory? Someone may say, here's 10,000 devices there in your service territory. Well, only 8,000 of them match account numbers in my CIS. So how do I now go broker the accepting and the rejecting of those folks? And then someone registered their device, but they really put it in their vacation home, and it's nowhere near my service territory. Or that device got sold on eBay, and now it's in a completely different city. How do we manage and detect free riders and just broker who's in and who's out of this program? Next slide, please. Here's the other big one. If I walked into Home Depot and bought a device today, well, I've got a relationship with Home Depot because I walked into that store. I got a relationship with the vendor that sold that device to me. My Wi-Fi router got bought somewhere else, and my ISP is someone else. So I've got 4 relationships already. But if I have an issue with my comfort or my bill, I kind of feel like I'm going to call the utility. I'm part of your program, so how does the utility now get the tools needed to actually manage this new version, this new range of billing inquiries and customer support calls? Next slide, please. There's a big paradigm shift going on here that we need to wrestle with. Should we and the utility mandate a standard offer to consumers? And if we don't, does that mean one bring your own device provider can give their customers say a fixed payment of $15 a year, and another bring your own device provider rewards their customers a different way, maybe in a certain dollar amount per event? And this is all to participate in one utility DR program. It probably facilitates competition and consumer confusion. So how do we mandate one offer, one standard approach to participate in a utility program and measure and dispatch that? Next slide, please. Another nuance is how do we actually facilitate settlement and payment? Are these fixed payments, or is this pay for performance? Are these payments going to the BYOD providers to pass on to their consumers, or is it on us and the utility to pay consumers by check or by bill credit? Next slide, please. So I picked and chose a couple of examples there. Our answer is we've built a big reference architecture of the business processes, the system functionality, and the integrations that have to happen in these areas: marketing, enrollment, unenrollment, forecasting, dispatch, settlement and payment, customer service, to handle all of these nuances of how complex it is to run a residential thermostat market. Next slide, please. So the upshot, a ton of functionality that most likely doesn't exist today in systems you have. And shattering the perception that building an integration to a BYOD head end via a proprietary API or maybe an open standard is not really a silver bullet yet. There's still a ton of stuff that has to be done to realize a true BYOD marketplace. So one more area that is really important we should look at. So next slide, please. This in itself is just one of the operational efficiencies that it's a big deal. But it's so big, it's worthy of its own item here. The marketing and program design of one of these programs. I think we all feel that the promise of BYOD is huge, but the uptake could be better. If you really want 50 megawatts of residential load next year, BYOD is not going to do it. It's going to have to be a direct install approach of marketing and installing devices and the utility having to pay for the asset. So how do we realize this promise? And here's a personal anecdote. That is, if I've walked in to, again, a trade or a retail channel and acquired a device, then I've already made a big decision about, I'm buying this thing, it's going to cost some money, and I'm doing it for a reason, for convenience and comfort, and so it can affect my bill. And later on, if I get offered a program to enroll in a utility DR program, that just comes across as a bit of a nuisance. I've already made this big lifestyle decision earlier. So we feel like there are absolutely some breakthrough marketing approaches so we can realize the adoption of BYOD into utility programs more than ever before, whether it be inventive point of sale rebates, whether it be mobilizing the trade channels out there. We've got to do some innovative breakthrough approaches to design and marketing to get the adoption we're looking for. Next slide, please. So here's the summary. It's very compelling benefits, right? The optionality we want to give consumers and the potential cost reduction of embracing BYOD is a big deal. We want to embrace this. It's absolutely a strategic opportunity right now. I would hesitate to guess that there's not a CIO or a DR budget maker in the industry who's not thinking about this, who needs a strategic solution to this strategic opportunity. And it's not going away. The prevalence of and the growth of the Internet of Things, smart devices working their way into our homes, means this trend, this is not a temporary bubble in the hype cycle. This is not going away. So it's time. It's time to actually embrace BYOD into existing DR programs, or if we're starting a new one, it be a combination of traditional direct install approach and BYOD. So thank you. It's been a pleasure. I'm going to pass the floor back to John for Q&A.
Thanks, Chris. We have a number of questions that came in, and I'll handle the first one. The question is, how does Converge suggest setting a baseline? We're comfortable with most of the standard baselining techniques that are out there today, where, for example, you average the 10 prior days, or you pick the 3 top of the 10 and average those. The one feature that we like in a baseline is when you have a day of normalization. So if your event day is hotter than your baseline days, you scale up so that you recognize that in the baseline settings. So the second question, maybe Chris, you can handle this one. Let me see here. I assume we are talking about C&I end users. How many retail customers participate in the typical DR program via third parties?
Well, I don't think we're talking about C&I customers. We're talking about residential and small business. And if the question is how many BYOD devices are enrolled in residential DR programs in North America today, the answer is not enough. Not enough. To my last point, we absolutely need to think of breakthrough marketing and design to truly adopt a statistically relevant portion of the devices that are working their way into people's homes via, or Wi-Fi connected devices that are working their way into people's homes via those channels.
Okay, very good, Chris. Thank you. The next question is, how does commercialized battery storage impact typical demand response programs going forward? Storage will help balance load shape throughout the day. This is absolutely true, but we believe that in the realm of distributed energy resources, which we classify DR in that category, you'll find that demand response is the most cost-effective solution that you can find. Admittedly, it doesn't have all of the capabilities of a battery, but when you compare demand response prices to battery prices, I think you'll see the value in a demand response program. Chris, here's another question, and you can take it or I will. You talked about utilities using AMI data. What about a utility who doesn't have AMI?
Well, that's really interesting. I mentioned along the way that there's tribal opinion about what data is valuable and not valuable, but we don't need to go with tribal opinion anymore. Machine learning and math tells us. So it is absolutely fine to move forward in a BYOD model where you can do good, decent prediction and forecasting without AMI data. And we have sort of statistical evidence to prove how accurate it is compared to AMI. It's not as good, but still completely doable.
Thanks, Chris. Another question that we have is, how many residential customers equal 1 megawatt of demand response? A rule of thumb, and again, it varies from location to location, and within a utility, it varies by area, but the rule of thumb would be a kilowatt per device for a HVAC program on a relatively hot day. We got another question here, Chris, on does customer self-installation serve as a barrier to participation for the vast majority of customers? Are there concerns about quality of installation compared to professional installation?
You know, I don't think so, for this reason, that with a thermostat, because it impacts, again, the person's comfort and bill, they absolutely do want it connected and online and controllable. And that's the only thing we really need to be able to use and harness it. We're assuming that person who's spent that money will be interested in getting it online and using it for their convenience. So it will be online and connected.
Thanks, Chris. The next question is there a proactive way for utilities to identify connected devices that are not participating in a program and market to them? I think that the way that this will have to be done is through the third parties. They have the knowledge of the customer, and they can access that customer via email, and they have interactions with the customer through their website. So I think that that would be the most beneficial way of doing it. If you were to market directly to the end customer, they would have to go through the third party anyway to enroll. So that's possible, but the third party has to be in the loop, so to speak, for these devices to be eventually useful. Let me see if we have another one here. Chris, we have a question on machine learning techniques. What sorts of machine learning techniques do you use?
Well, I think that's even a bit beyond me, and we should get the engineering team involved. In short, it's a very different technology stack to a typical platform, different databases, different tools. But regardless of technology stack, what they're doing is taking historical data and training a model that can be then used to predict as real-time new streams of data are coming in. The techniques involve things like determining which algorithm. There's a ton of machine learning algorithms out there. Which one is giving us the best results for this model? Techniques such as how to weight the data. Is AMI data the most important thing? Is telemetry data the most important thing? Is weather? Whether there's 13 different dimensions to weather, which ones are actually move the needle on predicting future? Plus also, the other big technique is determining whether to forecast individual premises and aggregate them, or to intelligently cluster like premises together and forecast them in clusters. And all those sort of techniques together are what help hone you in on a better forecast with those machine learning tools.
Very
Hopefully
good.
that answered the question. I think very open to a deeper dive with different folks.
Thanks, Chris. We have time for one more question. That question is, for type 1 providers of BYOD devices, and given a free hand, would Converge recommend pre-cooling? There's advantages and disadvantages to pre-cooling. So it would depend on the circumstances. One thing that happens with pre-cooling is you put additional load on the system in the hour prior to the event. So that limits the usefulness of this device because it has to start at the beginning of the event. You can't have a pre-cooling mechanism that starts 2 hours into the event because you have the pre-cool period within the event itself. So I think this is one of the functions of the aggregator, to figure out how one would deal with pre-cooling and where one could use it and where one would not use it. So it adds a layer of complication, but it certainly has its advantages in some situations. So with that, I'm going to turn it back to PJ to wrap this up. Thank you.
Thank you very much. For our audience, we hope you've enjoyed today's discussion. As you log off, please take a moment to complete our survey and give us your feedback so we can continue to provide you with quality content. Thank you for attending, and this does conclude today's presentation.